Okay, I think I got everything ready. I haven't made a video in a while, so bear with me if this doesn't go super good. But it should be fine. So I'm not gonna go through everything. Well, maybe I will, but I'm gonna jump around a little bit. I'm gonna try to hit on the things that you maybe care more about. So for number one, I think that there are some multiple choice questions kind of like this where you have to just think about function properties and stuff. So let's talk about this. Um, I think this one's fairly simple. Again, this is like the vertical stuff that I keep saying over and over again tends to be the easy stuff. But if you read through, it says the depth of water at a local river varies sinusoidally with time. The maximum depth of the river is 18 feet. Now, I don't know. Do you want to treat this as a negative 18 because it's talking about depth? You could, if you wanted to sort of plot this thing as negative values and have 18 be the lowest, and because it's negative 18, and then have 12 feet be less low and have them both negative. You could do that, but we could just define the y-axis to be depth, and then it's positive values, and you can see all your answer choices are positive values. So that's not what we're after. We're not after having you guys treat these as negative numbers. We're going to define them as depth, and therefore they're positive. But if the maximum depth is 18 and the minimum depth is 12, then to find the vertical shift, then you want the midline. And the midline is the average of those numbers. So add them up, you get 30. Chopped in half is 15. So it's D as in dog. The only thing worth talking about, I guess, is 3 is there as a choice. But 3 is the amplitude, right? So you'd want the amplitude if you were trying to write an equation. But again, it asks for the vertical shift, which means you want the D value of the function, which is the 15. Next. I'm giving you a function here, and again, I didn't really proofread this, so the fact that the B value is 60 makes me think that we're in degree mode. So it says, what's the period of this function? Well, if we're in degree mode, you'd be doing 360 divided by 60 to get 6 months. So the period is trying to be that 6 months there, so option A. Obviously, if we were in radian mode, then we'd be doing 2 pi divided by 60 and getting pi over 30, but that doesn't make sense in the context of this problem. We're talking about some number of months going by. 3 says, what's the maximum number of members that the gym should expect? Well, max is going to be midline plus amplitude. And we know the midline comes from our D value, so 100. And we know that from 100 they oscillate up by 20, down by 20. So if I add 20, we can see that our max would be at 120, our min would be down at 80. So 80 is the min, 120 is the max. So choose option D. Then it says, in what months should the gym expect to have its minimum number of members? So this one's a little weird, just because of the way I worded everything. But it says here we're letting time 0 represent January. Now normally you'd let January be month number 1, right? There's no such thing as a time 0. But since we've assigned January the number 0, then every month kind of has to be its normal number, but minus 1, right? So like July is the 7th month, but by our reckoning it would be 6. So T equals 6 would be July. So just don't let that mess with your mind. Anyway, how would you solve this? Well, looking at the equation, we have a non-phase shifted cosine. So that would seem to say that at time 0, we're at a max, because we're a non-phase shifted cosine. So that tells me, when should we expect to have our minimum number? Well, the minimum would come half of a period after the max, right? And then half a period later, you'd be back to the max. So we just found in part A that our period is 6 months, so 3 months later, so after time 0, hop out to time 3. 3 is the 4th month, that's April. But, hold on, it said in the first year, right? So that means 3 months later would be at a max, but then 3 months later would be back at a min again. So how's this work? 3, 6, 9. So the 9 is really the 10th month. 10th month is October. So the answer is C. April and October is when the gym should expect to have the minimum number of members. I did my best to make this actually make sense too, right? Middle of winter, people are going to the gym. Does that seem right? Trying to get their summer bodies back or something. And then in June, July, it's actually summer again, so they're trying to get their beach bodies. I don't know. I tried to actually make a thing that made sense. All right, moving on. All right. This is not really relevant, but I guess I'll talk about it super fast. But it says a certain sinusoidal function has a minimum value of 20. That would be here. And that 20 occurs at t equals 15. We'll let that be here, I guess. But basically they're saying there's an ordered pair here, and that point right there corresponds to a minimum. I don't really know what the graph is doing, but I know right there is a minimum. And I already hate that picture. Okay, that looks better. Hey, why did I bother changing my picture? Well, because this whole question actually boils down to the fact that sinusoids are always symmetrical over their maxes and mins. There's always a sort of vertical line of reflectional symmetry at those mins. So if you read on now, it says, hey, there are 2 points on the function where the y value is 24. So some random spot here, 24. Well, there'd be 2 points. Now, I don't mean 2 points ever, but there'd be 2 points per period. Somewhere else out here, there'd be 2 more points, and 2 more, and 2 more. But I think the point of the question is there's 2 consecutive spots where you're at a height of 24. One of them is left of 15, the other one is right of 15, and the whole point is there's a symmetry there. And this mattered before when I was asking my students to actually figure this stuff out without a calculator. You guys have a calculator now, if I were ever asking this question, but it says at 10.351, that's this. That's when we're at a height of 24, and I'm asking when we'll be at a height of 24 again. Well, you can exploit the symmetry of the situation here. So how much sooner than the 15-second mark is 10.351? Well, it's whatever 15 minus 10.351 is, which of course is 4.649 seconds. So based on symmetry, the next time that we're at that same height would be 4.649 seconds later. So we know the next time that we're at that height is 15 plus 4, that's not 14, just the 4, is 19.649. So it's that A value right there. And this idea sort of comes in handy when I was asking those questions about how long do we spend at heights that are lower than such and such. Well, once you have this number, you could just double that number. It actually would be 9.298. So if I was actually asking, how much time do we spend at times that are less than, or at heights that are less than 24, you could use the same idea of symmetry. This matters. I don't think it's exactly assessed on the quiz though. All right, next. All right, there's definitely a sinusoid question, so let's read through it, I guess. I kind of mentioned this in class, but it says Mr. F just finished setting up his winter holiday village in his living room, and the centerpiece of the display is an antique train that choo-choos its way around a circular track. All right, circular track. Beep. There you go. Periodically puffing smoke and sounding its horn. Woo woo. The train is fairly slow moving. It only makes its way around the track about 10 times per hour. The track is pretty big though. It's about 18 feet in diameter. That sounds like something worth writing down. That's 18 feet. And when the train is at its closest to the couch, it is only about 4 feet away. So bzz, this is a couch. And we are 4 feet away from the couch. And so what we want to do now is measure the distance for this little train. See this little train? Goes around its track. Woo, woo, chugga, 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 chugga. And so here at its closest, it's 4 feet away, which means here at its farthest, it's 22 feet away, which means here on the midline, it's 9 and 4, 13 feet away. Again, that's that vertical stuff I kept saying is pretty easy. Hopefully you guys agree. None of this is exactly what I wanted to talk about. I think probably you guys would be fine with all of that, which is good because you'll have to be. But it says, what's the period? I think you're fine with period. Up here where it mentioned that we only go around 10 times per hour, then that's telling you that in 60 minutes we only go around 10 times. So each revolution takes 6 minutes. So that would be a period. Every 6 minutes we complete a full cycle. The amplitude, well, the amplitude, whenever you've got motion around a circle, the radius of that circle is the amplitude. So the amplitude is going to be 9 feet. What is the maximum value? We just said it would be the 4 plus the full diameter, the 18, so 22 feet. The midline, well, the midline, we talked about that too, really. It would be the 9-inch radius plus the extra 4 feet of distance from the couch, so that's 13 feet. I don't know, depending on how I'm framing this, the midline value, what do I want here? I think just say the number in feet, so 13 feet. Okay, I think that's easy. Now use your answers from above to actually write the function d of t. Okay, sure. I'm sure what we meant to say here was to like draw a sketch first. Okay. Oops. Let me grab this little line. Drag it just off screen. Okay. So I would draw a sketch before I ever start trying to write an equation. And there's some info that I've missed. So right now I feel pretty confident in all my vertical dimensions. We said at the closest will be 4 feet away, at the farthest will be 22 feet away, and when we're in the middle, we'll be 13 feet away. So that's the easy part. The less easy part is, what function do we even want to write? So you got to keep reading up here. Find where it talks about time 0, or find where it talks about they started a stopwatch, but something that indicates that you have just begun to measure time, because that's always going to indicate your phase shift. So it says we want to do a point when the train is farthest from the couch as possible. Farthest means max, max means cosine. So we know that we want to write a cosine equation. So our period is 6 minutes. And we're starting on a max. So that means we'll get a point here, and then 6 minutes later is when we'd be back to a max. So that means 3 minutes in is when we'd be at a min, which means that 1.5 minutes in is when we're on the midline on our way down. 4.5 minutes in is when we're on the midline. Yoink, 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 yoink. There's your sketch. Once you've got a sketch going, writing the equation I think is cake. So we'll say d of t equals 9 foot amplitude, so 9 times the cosine of, let's stick with radians, so we'll go 2 pi over 6 is pi over 3. And then we'll go t. And we don't need a phase shift because we started right on the max. But we do need our midline of 13. Okay. So now it says, using your d of t from above, find the two values of t in the first period of d of t where the train is 10 feet away from the couch. So 10 feet, huh? So 10 feet feels like a kind of arbitrary value. It feels like the only way to find those numbers is probably to use our calculator. But I want to say there are some values on a sinusoid that you don't need a calculator to find. So just to point this out, and this is definitely important, by the way, but we're evaluating at pi over 3. So what if I had told you just to find the distance from the couch to the train after the first second. Well, if you plugged in 1, you get 9 times the cosine of pi over 3 times 1 plus 13. Well, that's completely evaluatable. It's the cosine of pi over 3. That's on the unit circle. Pi over 3 is like 60 degrees. So we are definitely supposed to know that the cosine there, the x-coordinate, is just a half. So this would be 9 times a half, so 9 over 2 plus 13, but 13 is 26 halves. So this is 35 halves. And you could leave your answer like that, but since this is a word problem, you could, well, even if this wasn't a word problem, you could give me this number as a decimal because it is a decimal that comes out cleanly. What is it, 17.5? But 17.5 feet is an acceptable answer here. And I can find that exact answer for 1 second. Even though 1 second feels like it's not one of my it's not one of my 3 critical values. It's not a max or a min or a midline, but still, because of where it falls on the unit circle, it's still completely evaluatable. So you do need to understand that. All right. Lastly, it says the antique train's batteries will only last for about 100 minutes of continuous use, assuming Mr. F forgets to turn the train off for the night. Then how far from the couch will the train be when the batteries run out? Essentially, I'm just asking you to find D of 100. So plugging that in, you would get 9 times the cosine of 100 pi over 3 plus 13. So this one too is evaluatable because 100 pi over 3, what is that? That's a hell of a lot of things. But guess what? 99 pi's over 3 plus an extra pi over 3? What is 99 pi's over 3? Isn't that 33 pi? That's 33 pi. That's an odd number of pi's. So if that's an odd number of pi's, that would land us right here on the x-axis, right? Would go around, well, 33 times, but would land here. Then we would go an extra pi over 3. So you're talking about a 60-degree reference angle again, but this time it's in quadrant 3. So this time you know that what you've got is 9 times negative a half plus an extra 13, which means this time you're doing negative 9 over 2 plus 26 over 2. So if I take 9 away from 26, I'm left with 17. Feels right to me. So 17 over 2, aka 8.5. So hey, check it out. It's another question that certainly kind of feels like I would need a graphing calculator, but I don't. I can just evaluate this by hand, and I can figure out that the train would be at a point that is 8.5 feet away from the couch after 100 minutes go by. This is totally doable. No, you don't need a calculator. All right, that happened. Next question should look familiar. Oh, okay, maybe not. I guess I didn't even copy it in. But the next question was the weight on a spring question. And I borrowed that weight on a spring question for the quiz that you guys took, so we don't need to go over it again because it's the exact same one from the quiz. But here's some graphing. But I believe you guys are good at graphing sinusoids, so I was going to skip it. I will come back to it if you want, just fast forward to the end. But I wanted to hit on the things that you guys really cared about. This is another sinusoid. This is a cosecant function. Will I do that now? I won't. I'm going to go way to the end, honestly. I think the things that you guys maybe wanted more practice with was writing the equations of tangent and cotangent and secant and cosecant. So there's a couple of those buried at the end. So go right to 15. If you haven't done this one yet, do it now. Pause the video and do it. And then I'll tell you what I think about it. Okay. So the other thing I said in class was I will make sure that if there's a tangent graph for you to write equations of, that the 3 critical values are really well labeled. You can see these are very well labeled. This point here for sure is the midline. So I can see that my amplitude going up is 1, 2, 3, 4. Well, It isn't 4. It's 4 boxes. But remember that every box is only worth a half. So this change from here to here is a change of only 2. Now the period for tangent is the distance from asymptote to asymptote. You could do that. I don't so much like that here because that's kind of wide. So what you could also do is, I don't know, find the distance from this point that lives above and this point that lives below. And I hope that's pretty obviously just half of a period. So I could take that distance and double it. And I don't mind that because now I can use that strategy that I often use where if I just kick this point 2 units right, but kick this point 2 units right as well, then clearly this whole distance just shifts over. And I'm now just trying to read off a distance that goes from 0 to pi over 6. So clearly it's pi over 6. But remember, that was only half. So you got to double that. And our true period would be pi over 3. And by the way, nobody asked for it, but that does imply that our b value is going to be 3, doesn't it? May as well jot that down now. All right, and then who's our vertical shift? Well, our vertical shift is just that distance up to the midline, which for us we can see is only half of a unit. But that's it. Now that I've pulled out all that data, I should be able to write my equations. The one thing is, if I say write me a tan equation and a cotangent equation, I'm not going to tell you that one of them has to be negative, but you know that one of them has to be negative. You should remember that tangent naturally is a function that wants to sort of straddle the y-axis. It passes through the origin and it's always increasing. The function we've got here though is decreasing. So if you're going to write me a tangent equation, it better be negative 2 times the tangent of blah blah blah. Now cotangent on the other hand, cotangent starts at its asymptote and then naturally decreases. So whatever cotangent function you write should go ahead and have a positive coefficient on it. It'll be 2 times the cotangent of so-and-so. All right, so what is all this stuff? Well, we just decided that since our period is pi over 3, we need a b value of 3. Then we need a variable, it says up here f of x, so just choose x. And we also need a phase shift, and as I'm showing you over here in the parent function, tangent needs to be phase shifted onto its midline. So we can see that a phase shift of pi over 24 will kick us into the right spot. So it's to the right, so it's minus pi over 24, close parentheses. Then we've got that little kick up, a little vertical shift, that's just half a unit up. But that should do it. This equation in tangent should model this function. Then over here, the cotangent equation would just be the same thing largely. It would be 3 times x plus or minus somebody plus 1/2. And so just remember that again, like I showed you on this little drawing, the starting point of a cotangent function is an asymptote. So pick the asymptote that's closer, that would be this one, and find that phase shift. So we're phase shifting pretty far here. It's that total distance. I did try to mark off exactly the units. See, it is just, I put it down there so it wasn't in the way on the x-axis. But it's pi over 48. If it wasn't labeled down here, then you know that you just take half of pi over 24, right? There's your pi over 48. What if that wasn't labeled either though? Good golly, what would you do? Well, it says right here, this is pi over 12, and my scale would be 1, 2, 3, it would be 1/4 of that. So pi over 12 times 1/4 is pi over 48. So you do need to potentially be able to figure out those scales yourself. But if that's pi over 48, what is our phase shift? It's 1, 2, 3, 4, 5, 6. It is 6 pi over 48. And so come hell or come high water, you guys are going to be reducing fractions, I hope. But I can reduce this. They're both divisible by certainly 2, but 6. They're both divisible by 6, giving you just pi over 8. So that's our phase shift, and we're going to the right, so it's plus. It's plus pi over 8. And that'll do it. That's a tangent equation and a cotangent equation. Hopefully that clears up any confusion. Now let's do the secant cosecant one. So for this, my advice, again, my strong advice, is just mark those maxes and mins and let those kind of stand in for the sinusoid that worms its way through the middle. I'm at a height of 8 and I'm at a height of 2, and the average of 8 and 2 is 5, so the midline is here at 5. If you can't eyeball it, just remember that the midline is the average of the max and the min, and that should make it pretty easy. That means there's a midline, so there's a midline point here, midline point right on the y-axis, another midline point here. Then you can even sketch the sinusoid in if you want to. I won't get mad about that. Doesn't seem totally necessary, of course, but you could. But now what that means is, I can recognize right away that I don't need a phase shift here for negative sine. So let's write a negative cosecant function, and that'll model our graph. So we didn't pull out any data yet, but this distance of 3 boxes, that's our A value. And every box does happen to be worth 1 here, so A is 3. Our period, we could go midline to midline and double it, but let's just go all the way to here. When I said midline, I meant asymptote, but the midline points are the asymptotes, so depending on what you were talking about. Oh, rats. All right, so this one again has an axis that I imagine is in degrees. So if that distance, though, is 36, you can treat that as just the number 36 if you want to. It's like 36 minutes going by or whatever. But your period, you have to express it either in degrees or in radians. I'm just going to stick to radians. So the period would be 2 pi over 36, aka 1 pi over 18. If we did this in degrees, of course, then that would have been 360 divided by 36 and would have had a b value of 10. I'm screwing this up, by the way, aren't I? Because that's not meant to be the b value, that's meant to be the period. So the period is indisputably 36. Is it 36 degrees though, or 36 radians, or is it 36 months, or is it whatever? Doesn't matter. Either way, it translates to a b value that, let's just work in radians. That is 2 pi over 36, aka 1 pi over 18. Now the vertical shift. The vertical shift is this distance that's taken us up to our midline, which is 5. Which means writing the equation now should be the easy part. We just decided that if we do a decreasing sine function, negative sine, then we won't need a phase shift. And so sine is the reciprocal of cosecant, so we'll write a cosecant equation where we have negative 3 times the cosecant of our b value is pi over 18. And we just said we don't need a phase shift, so it's pi over 18 times x, close parentheses, plus 5. And that's it. So you got your choice now. We just tackled this guy. I'll just mark it with an A. But now the other options are, do you want to write another cosecant function, but this time a positive one? Or do you want to focus on this guy here, which is the starting point of a positive cosine? So we could write a positive secant, which I think is what I want to do. We already did a cosecant, so now let's do a secant. And positive secant is associated with the maximums of cosine. And you got 2 of those, but I'm begging you to pick the smaller of the 2, so use that one. And so again, the only thing that changes is the phase shift, so we'll go negative 3 times the secant of pi over 18. Definitely need a phase shift this time, so x plus or minus somebody, but still plus 5 on the end. So what's this phase shift? It's 2 boxes, and we decided that each of these boxes is worth, well, it doesn't matter what they're worth. We can see that 2 boxes is 9. So they're 4.5 each, but for sure that means this is a change of 9. So plus 9 will put us in the right position, and we're done. That's how you write the equations of those. And that's kind of it. So as far as like new stuff that I feel like you guys could stand to practice, just sort of reading and understanding these word problems about sinusoids, being able to answer questions like that, I think that's important. So we did those. A word problem, specifically understanding this stuff down here about how you don't necessarily need a calculator to evaluate. Sometimes when you go to evaluate trig, it does come out to be a unit circle value. So if you've got a 3 down here, or a 4, or a 6, then pi's over 3, pi's over 4s, pi's over 6s. Those are all evaluatable. So don't reach for a calculator, since I'm not giving you a calculator anyway, but don't reach for a calculator. You can do it in your head. That was important to talk about. And then the other thing that's important was writing these equations. It's only important because it's what we spent the least amount of time on, but hopefully now, with all the time we have spent, you feel ready. So with that in mind, I'll do another graph, writing equations from graph, and then I'll backtrack and do everything else. Obviously, turn off the video whenever you feel like you don't need it anymore. All right, it says identify the indicated properties and write 4 possible equations. Remember, for sinusoids, we can write all 4 equations. For tangent, we can only write a positive tangent or a negative cotangent. So for tangent functions, there's only 2 equations, but for sine and cosine, there's literally infinitely many. Let's just figure out the stuff. Where are we? Hopefully it's pretty obvious. 1.5 seems to be our midline. We're getting maxes at 1/2. We're getting mins at 2.5. So that changes 2 boxes worth half a box each. That's 1. Amplitude is 1. Your period is going to go from max to max if you wanna, but again, I would say it's easier to just go from min down here to max up here, and then just remember to double that. We can see our scale is counting by pi. So again, if I push this over, then our total width would be from 0 to 4 pi. So 0 to 4 pi is half of our period. So our total period is 8 pi, which would imply a b value of stretch. So the reciprocal. So if I've been stretched by a factor of 4, the b value is 1/4. And then our vertical shift. Well, the vertical shift is this initial shift down to the midline, which seems to be 1, 2, 3 boxes, which is 3 halves in a downward direction. But that's it. We have pretty much everything we need now. We know the amplitude is 1, so we'll get 1 times the sine of, we'll get -1 times the sine of, we'll get cosine, we'll get negative cosine. But that's it. We just decided our b value was 1/4. All right. Is there anybody that doesn't need a phase shift? Nope, because the point on the y-axis is some random garbage point. So everybody needs a phase shift. So let's go find those phase shifts. I'm going to do the ABC thing again. So A is positive sine, so that would be a midline point on a stretch of graph that is increasing. That's a phase shift of pi. It went to the right, so x minus pi. And of course our vertical shift is down 3 halves. So that equation's done. Next is negative sine. So that would be a midline value on a stretch of graph where we're going down. This is 1, 2, 3 pi. So that means our equation would be x plus 3 pi. The plus is what pulls us left. And the same minus 3 halves on the outside. Okay, next. So positive cosine would want to start at a max. There's a max right there, and there's a max right there. But of course, you're not going to phase shift 5 boxes when you could phase shift only 3 boxes instead. So the cosine is going to be x minus 3 pi. And then the other cosine function, of course, goes with the min. So d will go down there. It's phase shifted 1 pi to the right, so it's x plus pi. And that's it. That's how you would write your 4 equations. Everything else is graphing, so if you're good on graphing, then you're good to go. I don't have to do this, do I? I guess I do. There's going to be like the one kid who came just for this, so fine. Where are we? 3? Where are we? -1? Seems like a total change of 4, so my amplitude must be 2. What's the period? Well, we seem to be going by tens. So if that's negative 30, 20, 30, 40, 50, and that's 50, then half of my period is 80. So the full period is 160, which would seem to imply, well, I don't know. You guys think that's degrees again or just some really big number? If you want to do this in radians, then you could do 2 pi divided by 160 to get pi over 80. I don't remember what I did on my answer key. I don't think I did anything. But I know that my mindset at the time was to do this in degrees. So if this was 360, then I could cancel the zeros. I could chop everything in half and get 18 over 8, it would be 9 over 4. So let's do this one as if we're in degree mode. Who cares? It's fine by me, sort of. So the b value would be 9 over 4. And the vertical shift would put us at 1 again. Alright, well that means that we're going to go 2 sine, negative 2 sine, 2 cosine, negative 2 cosine. And they're all going to have a b value of 9/4. Okay, then they all need phase shifts again, because again there's no critical value on the y-axis. Our critical values are here on a max, here on the midline, here on a min, and if I go way over here, then there is another midline value that we start from, which is a good thing because as we're writing the equation of sine, this is exactly the guy we need, the midline. So 10, 20, 30, 40, 50, 60, 70. So the phase shift would be plus 70. And of course we have the vertical shift at the end, which is just adding 1. So I can do that to all of them. Alright, so what else? For negative sign, you'd want to start here on the midline coming down. That's a 10 degree shift to the right, so it would be minus 10. Then we got cosine, which wants to start at a max. It's at 30, so it would be x plus 30. And then negative cosine would start at a min, which is sitting at 50. Yeah, that's fine. Okay, so x minus 50. But that's it. We wrote more equations. So the end of the packet's pretty good now. Going back to the beginning with just some graphs. I could graph these, I just don't really want to. But I'll do a couple. Alright, again, we're still doing a sinusoid. This time it's cosine. So to grab the amp, you just literally pull off that 3. There you go. Your vertical shift is the d value from the end, so that's 2 units up. The period comes from 2 pi divided by b, and since b is a half, we'll do 2 pi times 2 over 1, which is 4 pi. That means the increment is the period divided by 4, which is 1 pi, and we can see that our phase shift is 3 pi over 2. And with the plus here, we know that it's to the left. Okay, so first decision is I'll use the phase shift and the increment to come up with a good x scale. And I could go by pi over 2. Yeah, I think that's pretty perfect. So go by pi over 2. If we do go by pi over 2, then this will be 3 boxes at a time. And of course the pi will be 2 boxes at a time. Dog alert. That's a good boy. Okay. Keep it on the dog. Alright, what else? The y scale is pretty self-explanatory, like it almost always is. We got a 3 and a 2, so go by 1s. All right, now, what are we doing? We're going up 2, but we also have an amplitude of 2. So I would not put my line right smack dab in the middle. I would take that thing and I'd bring it down a little to account for the vertical shift. So I'd bring it down to maybe almost here. Sure. We're phase shifting left, but only by 3 boxes. So I think I'd put my y-axis near the middle, but skewed a bit left. I don't know. I like here. All right. And so now what? Yeah. Pardon. All right. So we're going 2 units up. That's going to be the midline. From there, we're going 3 units up. That's going to be the max. That's going to be the min. And our graph's going to fit in there. We're going to phase shift 3 boxes left. So that's where this function starts. And it's a cosine function, so it should start at a max. Right there. And now just follow the pattern. We're going to walk by the increment, which is 2 boxes. So 2 boxes over. Then we're going to go to that midline. Then we're going to go 2 boxes over, down to a min. 2 boxes, mid, line. 2 boxes, max. 2, 2, 2, 2. All right, now to graph, just connect the dots. And again, remember, if this is what straight looks like, don't draw it straight. Be bumping up above that. There's your concave downness. Then this guy curves under. There's your concave up, concave up, concave down, concave down, concave up, concave up, concave down. There it is. So that's a cosine function. Number 9. Amplitude is 2. Vertical shift is 1 unit down. The period is 2 pi times 3, so 6 pi. So the increment is 6 pi over 4, which is 3 pi over 2. And the phase shift, well, there's a little note here. I don't remember if we really talk about this on the test. I don't think we do. But I'm saying use periodicity to deal with the large phase shift. So periodicity means that I never should have said that the period was 6 pi. If we're working in terms of degrees, you'll do everything in terms of degrees. So what is 6 180s? That would be 600 and an extra 480. So that's 1080. So the period is 1080. So maybe we don't actually have that big of a phase shift after all. We don't. So good. That means I can go ahead and just pretend I never said the word periodicity. Don't worry about it. You don't need to know it. Let's just stick with the phase shift of 405. And if we're working in degrees, then our increment would actually be the 1080 divided by 4. And 1080 divided by 4 is 1080 chopped in half twice. So 540/270. All right. What are these numbers both divisible by? I don't like it. If we divide by 5, you get 81. If we divide by 5, you get 54. Okay, so that's a 5 and a 54. That's a 9 and a 6. This is a 5 and a 9 and a 9. This isn't really helping me, because I need the least common divisor. Alright, so I can squeeze a 3 out of this too. 3 and a 2. And a 3 out of this. 3 and another 3. I don't remember how to do this. I think I want everything common, right? 5 and 9. I don't know why I say right, like you guys are out there listening. But 5, 9, 3. Where does that multiply together to make 9 15s? 3 45s, 120, 135. So 270 is 135 times 2. And this apparently is 135 times 3. Alright, and no, I don't know what the hell I'm doing right now. If you guys don't have calculators, you'd never be asked to notice that both of these guys are divisible by 135. But that's our scale, so that's what we're going by. We're going to go by 135 degrees at a time, and then our phase shift will be 3 units, and our increment will be 2. And that hopefully makes sense. Our y scale, mercifully, is we just get to go by ones. I don't think anybody cares about this anyway, honestly. I think you guys are good at this part. Which is probably why I should be skipping it, graphing the other guys. So let me finish this one and then I'll do that. But what are we doing? We're going down by 1, so whatever. This will be my x-axis. That is as straight as I can do on this stupid tablet, so deal with it. We're phase shifting left after, actually. So I'll just put this in the middle then, because we're going to end up going left anyway. Not that far left. Alright, whatever. -1, boink. Up by 2, boink. Down by 2, boink. So all my y values will land there. We're going to phase shift. We just decided this was 3 boxes here. And since we're plotting a sine function, we'll start on our midline. So there's our starting point. Now our increment is 2 little squares at a time. So I'll go 2 squares, 2 squares. And now it's the same. We've seen this 100 times before. Over 2, up 2, over 2, up 2, over 2, up 2, over 2, down 2, over 2, down 2, over 2, up 2. That enough? Yeah, that's perfect. All right, let's connect the dots carefully. Okay, looks good. So no more sinusoids, but sure, we'll do Cosecamp. This is more of the same. Your A value is 2. Your vertical shift is 1/2 of a unit down. Your period is 2 pi divided by 5. Or maybe it's degrees again. Pretend this said pi over 4. Our increment would be times 1/4, 2 pi over 20, aka pi over 10. I'm not loving this. Then our phase shift I said was pi over 4. Not loving that. But then again, maybe I do love it. So we wanted a common denominator, which is 20. This would be 2 pi over 20. This would be 5 pi over 20. And once you get that common denominator, we can see that we'd have an x scale of pi over 20. The y scale is, you know what? It's not 1 because our vertical shift is 1/2. So we'd have to go by halves, which would space things out for us. By the way, now that everything's expressed in terms of the pi's over 20, you might make a note that our increment now is going to be 2 boxes at a time. And our phase shift is 5 boxes. So big long phase shifts aren't a big deal, but you never ever want to have a giant increment. Like if you're plotting points and the next point is 6 units away, 6 units away, 6 units away, then you're never going to fit 2 cycles, first of all, and also just the graph feels all wonky. But we're fine. Where we're at right now, we're fine. Let's get an x-axis in here, and it can go anywhere. Except off kilter. All right, then let's get a y-axis in here. We're going 5 boxes left. So whatever. I'm still going to cheat the axis left a little, and then we'll start 5 units over and have tons and tons of real estate to the right of us. So what's happening? We're vertically shifted by 1/2 of. Oh. Alright, I did my math wrong, but that's okay. So we're going down by 1/2, then we're going down by 2, which is actually 1, 2, 3, 4 boxes. So now I don't love that. 1, 2, 3, 4. It doesn't really matter. I've only got room up top for 4 boxes. Down here I only have 2. Might be better if it was 3 and 3. So I'll just drop the whole grid down. Okay, great. Now I've got room for my curve. Alright, we are graphing cosecant, which is the reciprocal of sine. So when I do my first phase shift, that brings me 5 units to the right. I'm getting a midline point, but those midline points are asymptotes. So maybe just draw the asymptote. Alright, now, once we have a starting point, we use the increment. We're counting by just 2. So we go 1, 2. And after our midline would come a point that's out of max. So a point there. Then in 2 more units, we're back on the midline, so we get another vertical asymptote. Then in 2 more units, we're down at our min. 2 more units midline, so asymptote. Then 2 lines over from there, we're back to max. 2 lines later, another asymptote. 2 lines later, min. 2 lines later, asymptote. That's it. That's everything we need. So now we know that what we get is this shape, a little U shape up here that's asymptotic to both sides. Then we get another one over here. This one's concave down. Then we're back to the concave up one, which I'm drawing not super well, but that's okay. You get another one of these. Okay, but that's it. That's 2 periods. That's all I asked for, and there's your 2 periods. Alright, another secant. Don't feel like doing it. Another cotangent. I'll do the cotangent, and then I gotta call it because I'm getting quite tired, and this is getting late as well. Alright, the A value is 2. The vertical shift is 1 unit. Down. The period is 1 pi divided by 1/3, so 3 pi, which makes the increment 3 pi over 4. And the phase shift we can see to be pi over 2 to the left. Which I'm not even going to write down. Pi over 2 is going to be 2 pi over 4 for us, because we want to be able to compare it to the increment. And we can see that we're going to want to go by pi's over 4. And yep, 1 still works on the y scale. We're going down 1, so no big whoop. Alright, there's my axes. Now what? Now start plotting points. What are we? Cotangent? Cotangent's the one that decreases, right? And starts on its asymptote? Okay. So if I phase shift 2 boxes left, 1, 2, then the first thing I should see is an asymptote. Then we now use the increment. We're going to go 3 boxes at a time. 1, 2, 3. And the next point, since we descend, would be one of our max points, which I don't remember where that was because I didn't mark it. Our midline was down here at -1. And our amplitude was 2. Okay, that's fine. So now what? From the asymptote that lies here, we're counting 3 boxes. So 1, 2, 3 would be at a max. Then 1, 2, 3, we're on the midline. 1, 2, 3, down at the min. And then 1, 2, 3, asymptote again. Yeah, seems fine. Do it again. From here, the max value, so to speak. 1, 2, 3, 1, 2, 3, down 2, 1, 2, 3, down 2. Okay, just connect the dots now. Again, remember what straight looks like? And for this thing, dip under that and then go up, 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 up. Same thing here. This is straight. Be over that and come down, down, down. All right, so this one, up, 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 up. And this one, down, 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 down. I missed it. That was terrible. Down, 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 down. All right, that's cotangent. I can't do any more. It's too late for me to do more anyway. But there's just a second tangent graph that you can probably do just fine. There's a second secant graph you can probably do just fine. But I'm quitting. Goodbye.